We know that the volume of the sphere of radius r is 4/3 pi r cubed. We now know how to use calculus to find the volume of a solid, which is the definite integral from a to b, the area of the cross-section dx. To confirm the volume of this sphere, we will slice the sphere perpendicular to the x-axis so that the cross-section will be circles. Imagine if we were to slice these spheres or these balls, then the cross-section is the perfect circle of radius r. This radius r is not the same as the radius of the sphere. This is the radius of the cross-section only. The area of this cross-section is A equals pi little r squared. We position the sphere so that the origin is at the center, the horizontal axis is the x-axis, and the vertical axis is the y-axis. Then the radius is y. It is the distance from the horizontal axis to the point x, y. The radius of the cross-section is therefore y. In this case, the thickness of the cross-section is delta x because we slice it perpendicular to the x-axis. The volume of this sphere is the area of the cross-section pi r squared times the thickness delta x. This is pi y squared delta x because the radius is y. We now need to express y in terms of x, but we see that x squared plus y squared equals r squared is the equation of the big circle. Y squared is therefore r squared minus x squared, so v sub I is pi times y squared is now r squared minus xi squared, and we bring down delta x. The volume of the sphere is the sum of the volumes of the cross-section, where the volume is the Riemann sum, pi times r squared minus xi squared delta x, which is the definite integral pi, the integral from a to b, r squared minus x squared dx. It remains to evaluate this definite integral from a to b, where the lower limit of integration is negative r and the upper limit of integration is positive r. We slice it from negative r to positive r. The volume is pi, the integral from negative r to r squared minus x squared dx. This is 2 pi, the integral from 0 to r squared minus x squared dx using symmetry. We then find the antiderivative and use the fundamental theorem of calculus to evaluate the definite integral. We plug in the upper limit of integration, positive r, and the lower limit of integration, 0, because we double the integral already. This will be 2 pi times the quantity r cubed minus 1/3 r cubed. This is 2 pi times 2/3 r cubed. 2 pi times 2/3 r cubed is 4/3 pi r cubed. So we use calculus to confirm the volume of a sphere of radius capital R.